Okay, so now let us look at again the visualization of categorical variables. That's when you have more than one categorical variable. So let's start with particularly two categorical variables, okay? The two categorical variables. So with that, again, over here, we load our data set. This line of the code load our data set. We are able to clean the data set using this line of the code, and then we have attached the data set, okay? So what we are actually going to do is we are going to create, so there's the head of the data, and there's a summary of the data, okay? So we have these different variables. So we have smoking status, and then we have gender of the individual. Again, which there's the hints data, okay? So let us create a two-way table, okay? So this is a two-way table with smoking status at the row and then gender at the column, okay? So let's create let's assign it to tab. So we are creating two-way table, assigning it to what tab, okay? So now if we run the tab, you can see that it has a smoking status. And then if you want the sum of the sum of the rows and totals, we can use the margin, add margins to see the sums of the rows and totals, okay? And then also we could have just do prop dot table, okay? Prop dot tab. There's our tab, which is the table we created, okay? To be able to get the proportions of the rows and columns, okay? So this one is actually giving us the proportions for each of the columns we have in the data, okay? So we have these columns, whatever it is doing is actually taking the total of the table and then being divided by the table total. So this actually is taking the numbers over here and dividing it by the table total, okay? And those give us the proportions, okay? Then now, we can actually use the prop margins to be able to know. So you can see that the margins again add margins function of the prop dot table of our, this tab is representing the smoking and then the gender, okay? And then add margin functions allow us to be able to see the sum of the rows and then the columns, okay? And then the total proportion is 1, okay? So next, we are also able to we can create a legend, okay? So for instance, we already know our tab is representing smoking and gender. So we can create bar plot of what? Of the tab. And then we have the legend. We want the legend to represent the row names, okay, of our tab. Okay, so the legend should represent the row names. And that allows us to create what is called the stacked bar graph, okay? All right, so there's what we have. So there's the stack bar plot. So you can see that. So we have the columns represented here, and then the rows is representing each of the colors within each bar, okay? Now, we can also go ahead and even use what is called the rainbow colors to be able to see the differences very well. So we want, given that our rows represent our rows is representing 3 rows, we want actually rainbow of 3 colors, okay? And that is actually going to give us a bar plot for the gender with each color representing the smoking status within each gender. Okay, so this is what we have. So now we are able to actually observe and then see we have the red one representing the level of the smoking status 1, green representing smoking status 2, and then we have smoking status 3, okay? And then we can actually measure it. So the red one, red combined to green, green combined to blue, then we get the what? The third levels, okay? Now we can even make it better by actually adding the title of the graph, which is very important. Whenever you display a plot, you have to be able to have its title, right? So we can say that instead of stack bar plot of gender by smoking status, or gender by smoking status, we could have just a distribution of gender by smoking status, okay? But let's just leave it as stack bar plot. But you have to give it a meaningful title whenever you are working on a project. Okay, so let's run. Okay, so now we have this plot. So also, again, this is just a repetition of our tab. We are assigning the smoking status and gender to tab, okay? Now, what we can actually do is also to have a bar plot of the tab, and then we set that beside equal true, and then the legend should be what? Should be the tab. Let's run this one. And so this one right here gives us what is called the cluster bar graph or bar plot, okay? So the cluster bar plot, there is a cluster bar plot, and the previous one, what we did was the stick bar plot, okay? And that is we using this argument within the bar plot function that is beside equal true, okay? Now we can add colors to make it look more beautiful, okay? So we can add colors, and then we are able to, and then again, remember that we said that the legend would give us the names for each of the clusters within each column. Okay. Then we also have, we can also beautify it by again giving it the name of the graph, the axis labels, which is the x-axis labels, the y-axis labels, okay, which is something you should always do for any project you have to help readers to better understand what you are doing. Again, rather than having a bar graph of smoking status versus gender, you can say a distribution of smoking status by gender, okay? So let's run it. So this is what we have. So we have the gender is, and then we have the smoking status representing each of the colors of the what within the clusters of gender. So next we can also have cluster stack bar graph, which is a combination of the cluster and then the stack bar plot, okay? So again, we have our tab, which is creating a two-way table of smoking and gender. Now, once that have been created and run, which we've already done, so within our bar plot, we bring the table, which is a two-way table. We need beside equal true, which gives us the cluster bar plot, okay? And then now we are able to have the main, which is the title of the plot. We are able to have the color, which is we want the rainbow colors. We have the X label, we have the legend, which is the number of tab, okay? Which should give us the legend. And then that the number of rows within the tab. And then also we have the frequencies. And then we also have what within it, we can also have what is called the Y lim, which means we're actually creating Y, the limit of Y, which is from 0 to 200, okay? So we can go ahead and then let's run this. So this is how this one look like, which actually give you the cluster and start chart, which usually is not highly something which is recommended when doing project. It's either you do the stack or the cluster. But to do combine, usually that's not something you might want to do for projects. But either way, it's possible to have them combined, okay? And then, so within the bar plot, remember you can also include the labels. So rather than having these labels right here, which is 1 and 2, you can include label male and female by creating the labels as we did earlier on in one of the visualization. Okay, so we also, if you have a discrete variable, let us create a discrete variable, okay? So a discrete variable in which we are creating a vector, okay, of this, we are naming it data, okay? So this is our data we are creating. Now, usually mostly if you have a discrete variable, you might want to plot something like, let's say, a dot plot, and that's what we actually want to do here, okay? So let us look at this length of the data give us how many do we have in the data. So if you run n, it gives us, we have 16 observation or values within this vector, which we call data, okay? Then we are going to create a table for this, okay? So we say table of data, which we are naming it freq, which is the frequency. And if we run the frequency, we are able to observe how many ones do we have, how many twos, how many threes, how many fours, and how many fives, okay? Now we can find the relative frequency, which we use the prop.table to find the relative frequency of our table, okay? So we can run it, and then we can actually say, this gives us the relative frequency for each of the categories of the discrete variable. And then we can use the cum sum to find the cumulative frequency, the cum sum function, to find the cumulative frequency after we have calculated our relative frequency, okay? So we are assigning it to cum red dot freq, okay, which gives us the cumulative frequency. So now we can decide to run this one, and that gives us the cumulative frequency, okay? And remember, cumulative frequency, the last category is equals to what? 1 or 100 if you are dealing with percentages. And then we have the freq table, where we are going to have our C-bind of the relative frequency and then the what? The cumulative frequency. So we have the frequency, the relative frequency, and the cumulative frequency. And that's something we are creating. And that's how by ourselves we can also create a relative frequency table, okay? So now let us run it and then see. So now this is a relative frequency table, okay? Giving us the frequency of each of the categories, the relative frequency or the percentages, and then the cumulative frequency. Now we can actually generate a dot plot from that using the function which is called dot chart, okay? So within the dot chart, we call the data in which we created, which was this data, okay? And then now we can actually name it, give it a title, which is called, we say, dot plot of discrete variable. The X, we call it value, and then the Y, we are going to call it what? The frequency implicit, okay? That's the name we are actually giving it. So let us run the entire line of the code. And now you can see the dot plot, which is giving it the frequency. So the dot is representing the frequency for each of the categories, okay? Now, rather than this, the frequency of each of the categories open up, we can actually bring them together, okay? So we are actually going to use what is called a strip chart, okay? So within the strip chart, we are going to use a method called a method. We are using a method argument, which we are going to call a method called stack, okay? And then we are going to have an offset of 0.5, and there's the type of how we would want to see, the plots within the dot plot. And then this is the name we are giving it, okay, which is the stick dot plot of district. Okay, so let us run it and see. Once you run it, you can see now it brings the over here, rather than being very disseminated around. Now within the strip chart, it brings them together. So how many ones do we have? 3. How many 2s we have? 4. How many 3 we have? It is the same thing as this. The only difference is that this time it has been able to combine. Okay, so there's how we can actually also get visualization of 2 categorical variables. Okay. All right, so I'll see you in the next lecture for more visualization.